Okay, were you able to find the period of that picture? The period of the picture is 1, 2, 3, 4. Yep, you are exactly right. So what would f of 6 be? F of 6 would be the same as f of 2, for example. So that's 1. How about f of 41? F of 41 would be the same as f of 1, which is 0.3, 0.4, something like that, right? Good? All right, next. An angle is shown in standard position. Estimate the sine, the cosine, and the tangent. Now notice, what's the radius of this circle? 1. So the cosine will simply be the x-coordinate. So what is the estimated x-coordinate of that point? Well, now, maybe we should do, I think they want us to do a decimal there. So what decimal would that be? 0.85. About 0.85 negative? Negative 0.85 would be our cosine. And what would our sine be? Negative 0.51 or something like that. Maybe just negative 0.5. And what would our tangent be then? What's tangent? Y over x. Sine over cosine. So whatever we said the sine was, negative 0.5, over whatever we said the cosine was, negative 0.85, whatever that is, that decimal, that would be your answer. And I think that is the point, negative root 3 over 2, negative 1/2, but I think we're supposed to do decimals. A central angle on a circle of radius 8 inches has an arc length of 6 pi inches. Find the measure of the central angle in radians. Okay? So what do you think? It's real easy. Don't overcomplicate it. It's real thing. Gabby?
Would you just divide it by 8?
You would just divide. That's exactly right. Because remember, guys, what a radian is. A radian is an arc length of radius length, the angle that's formed by an arc of radius length. So here's our situation. Not drawing this to scale at all, but the radius is 8 and the arc is 6 pi. Every 8 here makes a radian, right? So if you want to know how many radians there are, you're just going to take 6 pi and divide it by 8. So what, 3 pi over 4? The 9 points on the perimeter of the circle are equally spaced. Okay, so these are equally spaced, you guys. This is not your unit circle. These are equally spaced. So we got one here and here. Okay. Your job is to find the one that's 14 pi over 9. Any guesses here? How many points are around that circle? 9. So if there's 9 points around this circle, won't this first one, I got one at the origin, won't this first one be 2 pi divided by 9? Won't it be a 9th of a revolution? And then this one would be another 9th, 2 9ths. I know some of these reduce. Does that make sense to everybody? 9 points evenly spaced. Each arc is a ninth of the revolution. So it looks like that point right there is pointing. So far, so good. Ooh, the next one can be very time consuming. All right, so we're gonna skip it for now. But I would love to see what you come up with. Don't Google it. Figure it out yourself on your own time and bring it to me Monday morning, okay? I want you down on your own time though.
Which one?
Huh? Number 5. Number 5, okay? Now, number 6, here we go. The thing about number 5 is make sure you can only use each number one time.
You have to use all the numbers?
You can't, there's only 6 points.
I don't know if you can
9
combine
numbers.
them to make it like 62.
Okay. Alright, here we go. True or false? For an angle in quadrant 1. Okay, stop. Do you see where I got that? It said I'm between 0 and pi over 2. So I am in quadrant 1. Is it true or false that the sine of an angle is equal to the cosine of its complement? This is for, what are you talking about, complement? Well, what's pi over 2? Pi over 2 is the same as 90. So the angles I'm looking at are theta and 90 minus theta. Pi over 2 minus theta. Doesn't that mean, like, if this is 40, then isn't this going to be 50? They're complements. So is it true or false that in quadrant 1, the sine is equal to the cosine of its complement? Well, we don't even need to draw a picture, I don't think, because that would mean that the cosine of 60 is the same as the sine of 30, right? That's what we're checking. Is that true? What's the sine of, or cosine of pi over 3? Cosine pi over 3? 1/2. What's the sine of pi over 6? 1/2. What do you think? I think it's true. Let me draw the picture and prove it to you. If this angle is theta, this one up here would be pi over 2 minus theta. Make sure you're thinking about that, okay? This is 90. So if that's theta, that one has to be 90 minus theta. Let me label my sides here. What is the cosine of theta? The cosine of theta is x over r. What about the sine of theta pi over 2 minus theta? Now be careful. Be careful. What's the sine of this angle? Opposite over hypotenuse. Don't they match? Now some of you are freaking out because you're saying, whoa, whoa, what do you mean a sine has an x in it? Remember, that's not theta. That's a different angle.
Wait, can you explain how the sine, like, can you do this second, the sine again? I don't understand your gut.
Okay, here's the angle, right? Here's the angle. In a right triangle, what do I know about sine? SOHCAHTOA. Sine is opposite, and opposite, I'm talking about this angle now. Opposite would be x. Hypotenuse r. So the idea is the adjacent for angle theta will be the opposite for its complement.
Oh, I see.
Right? So the cosine of theta will be the same as the sine of the complement.
So like the formula is like when it's sine equals y over r, no sine equals x over r, it only applies when the angle's.
At the origin, in standard position.
Okay.
Gotta be in standard position. Here, I have to compare a whole different angle that happens to be in the triangle, but I can't use those definitions because I'm not in standard position. All right, how about B? Do 11 pi over 3 and negative 4 pi over 3 have the same reference angle? And what we mean by reference angle is this. Where is 11 pi over 3? Where is that? Think about your circle. Where would 11 pi over 3 be?
Quadrant 2.
5 pi over 3? How'd I do that? I took out a period, just like you did in problem 1. When you were subtracting 4, I'm subtracting 2 pi. That's my period. So 11 thirds minus 6 thirds is 5 thirds. So I'm right here. Now, if I made a triangle, this is called the reference angle. That reference angle is pi over 3. Would you agree with me? This is a pi over 3 angle. It just happens to be in quadrant 4. So it's called 5 pi over 3. What about negative 4 pi over 3? Isn't that right here? Right here. What is the reference angle for negative 4 pi over 3? Isn't it also pi over 3? Yes, they're both pi over 3 angles. So they're going to have the same reference angle. They're pi over 3s. Their point's going to be the same, except for signs, negatives.
What is the definition of reference angle?
The reference angle is when you build a triangle, it's the acute angle at the origin. Right? Now, we are memorizing our unit circle because that's a requirement, but if I don't have it memorized, like I have classes where we don't memorize it, we figure it out each time. If I know that angle's 60, then I know this side's root 3, that's 1 and that's 2. Well, this is going to have exactly the same triangle because that's 60. Now, the signs are going to be different, and that's okay, but it's a 60-degree triangle. It's a 30, 60, 90 triangle with a 60 at the origin. That angle at the origin is called the reference angle. And it's going to be pi over 3 for every pi over 3 angle on your unit circle.
So any question, if it's asking about a reference angle, if it's anything over, if they're both over 3 or if
Yep.
they're both over 4, if they're both over 6,
Yep.
then it's true.
Now, the only thing you have to be careful is when you start putting them over 6, if it reduces to an over 3, like if it's 4 over 6, then it wouldn't.
Okay.
But
What if it's a 4 and it reduces to
Huh?
over 2? That would be different also.
what?
If it was like 2 and they both said over 4 and one of them reduced to over 2, would that be different?
Yeah. It's going to be a different angle. Because remember, pi is 180. If you divide pi 180 by a different value, you're going to get a different answer. All right, evaluate. I think we did this yesterday. What's the cosine of 7 pi? What'd you say? -1. He's exactly right. Why is it -1? It's a bunch of spins with a pi left over, right? So there we go. Tangent, negative pi over 3. Negative pi over 3. That's right here. I already have it drawn, but you should know that. Negative pi over 3. Tangent would be negative root 3. Negative root 3. Why is it negative? Because in quadrant 4, y is negative and x is positive. So when you build the fraction, it's going to be negative. Sine, 13 pi over 2. It's going to be 90 degrees. It's going to be straight up. That's exactly right. Because 13 halves, can't we take out 12 halves? Take out revolutions. So it's pi over 2. Straight up, the answer is 1. Good. All right, which angles are coterminal with 11 pi over 6? How do we find coterminal angles?
End at the same spot.
Add a revolution. Yeah, that's what it means. They hit the same spot. So you either add or subtract a revolution. So figure it out. There's probably more than one. I need to take attendance real quick. I'm missing Sophia.
Turn off on the same angle, the same point, right?
Yeah, you end at the same place. They're not the same angle. They end at the same place. So you add or subtract a revolution.
Number 5.
I'm not taking the answers till the morning. Okay? Just because you are constantly unfocused. Okay, all right. Kellen's up here. I got all the answers. Let's hear them. What do you think? Which ones?
I got B and G.
B and G. He got.
That's not all the answers.
Well, let's just wait a second. Let's check. Are B and G some of the answers? So if I take 11 pi over 6 and subtract 12/6, I get B. Good. That's a good one. If I take 11 pi over 6 and subtract 24/6, I get G. Good. I go along with those. What are some other things people think? F. F, I am taking 11 pi over 6 and adding 12/6. That would work. C? I think C bothers me. Because remember, what do I have to add? What do I have to add? I have to add 2 pi. So I have to add 12/6? Yeah, so C is not one. A, now remember, I have to add or subtract 12/6. I have to add or subtract 12/6. Now, let's not get confused. You might be getting confused. They all are over 6. Therefore, if I drew them, they would all have the same reference angle. But they won't all be in the same spot. Coterminal means they are in the same spot. Okay? And you can only be in the same spot if you are adding a revolution or subtracting a revolution, which in this problem would be 12/6. All right, for which angles between 0 and 2 pi is the cosine -√3/2? Let's just start there. Where is x -√3/2? It's gonna be 2 and 3, but what angles? 5 pi over 6 and 7 pi over 6. Now where will the tangent of those two answers, 5 pi over 6, 7 pi over 6, where would the tangent also be a negative number? 2. 5 pi over 6. Tangent will be negative in quadrant 2. It'll be positive in quadrant 3.
Coterminals like the same as reference angle?
No.
Like,
Reference angle means, a reference angle is when I draw the picture, this little angle right here is the same size.
yeah.
So with my angle, I didn't mark this, but that's your angle, 5 pi over 3.
I was just making sure.
That angle, and this was 2 pi over 3, and -4 pi over 3. They have the same picture, they're gonna generate a 30, 60, 90 triangle with a 60-degree angle at the origin, okay? That's what it means to be a reference angle. That's your reference angle. Lots of angles. Every pi over 3 is gonna have the same reference angle, okay? Coterminal means it not only has the same reference angle, but it is in exactly the same spot. These are not coterminal because they are not in the same spot.
Okay.
So I have to pick an angle and then go around 2 pi, and I'm right back at the same spot, either way, right?
Yeah.
Forwards or backwards around the circle. All right, so your answer to number 9 is 5 pi over 6. Without a calculator, put the following in order from least to greatest. Which one is the smallest? Cosine 9 pi. Because what is cosine 9 pi? -1. So that's the smallest. Which one is next? Sine 9 pi? Because sine 9 pi is 0. Which one's next? Sine 11 pi over 4, because it is root 2 over 2, or 1 divided by root 2. And then what's cosine 10 pi? 1. Yeah. Yeah. So cosine 9 pi, sine 9 pi, sine 11 pi over 4, and cosine 10 pi. Now, number 11 is asking me, it's kind of like the one we did earlier, but it's asking me for the exact coordinates. But they tell me the angle is 5 pi over 3. So what are the exact coordinates at 5 pi over 3? 1/2, comma, negative root 3 over 2. 1/2, negative root 3 over 2. Those are the exact coordinates because it's 5 pi over 3. Without a calculator, find each of the following. Okay, now I want to look first at problem C.
For number 11, I'm just confused because I thought the coordinates only worked if it had a radius of 1. Because point
Oh, shoot! You're exactly right, Fred. You're exactly right. You're exactly right. So, we have to find the exact coordinates.
Fred.
Yeah, good job, Fred. Fred is paying attention. His mind is sharpened by his physics test,
Thought Fred's gonna be an engineer.
and he is thinking. So,
5 nights
Um,
at Freddy's.
on the unit circle, it would be, what do we say, 1/2 negative root 3 over 2. But we need the x and the y when the radius is 5. So we'll take 5 times 1/2 and 5 times negative root 3 over 2. So Fred is exactly. So 5/2 negative 5 root 3 over 2. Does that make more sense, Fred?
Yeah.
Thank you very much. You had it too? Kellen had it too, he just was too scared to say anything. Okay,
Nah, Kelly, you didn't have it, bro.
all right, now we're on number 12. Okay, are we ready for 12 now?
Yup.
I want you to look at C. What happens when you add 4 pi? Nothing. So the answer to C will automatically be 0.86. Would you agree with that? Nothing happens. Now, I want you to look at B. B references negative alpha. Well, if alpha is over here, and it's negative 0.51, 0.86, so this is alpha, right here, this is alpha. Wouldn't negative alpha be right here? Yes, negative infinity. And where would, or what would the coordinates be for negative alpha? Negative 0.51, negative 0.86. So for problem B, the answer is negative 0.86. Does that make sense to everyone? All right, then let's go up to A. A is negative alpha plus 2 pi. I turned it around. But wait, what does adding 2 pi do? Nothing. So that's going to be right here. And we want cosine, so the answer is negative 0.51. Now, what about D? D says, take alpha, here's alpha right here, this is alpha. But now, add pi to it. So pi is just gonna be half a revolution. So if we add pi to this thing, are we gonna end up right down here? And what will be the coordinates at that point? That's alpha plus pi. What will be the coordinates at that point? 0.51, negative 0.86. Problem D wants the cosine, so the cosine is 0.51. And then E is negative alpha plus pi. Negative alpha plus pi. Well, here was negative alpha. If we add pi, aren't we going to be right here? We want sine, so 0.86.
Do you just go pi? Like, these are the coordinates for 2/3 pi, or 2 pi over 3. Do you?
Yeah, but what if they're not? It works the same way. So that's right, you're exactly right. So with our specific example of 2 pi over 3, we can actually see it working as we go around 4 pi over 3, you know, but it's gonna work for everything, not just a special one. All right, let me give you something else here now that I want you to look at. This is called odd one out. So I'm gonna give you a paper, okay, that has 3 items in each row. I want you and your partner, if you're by yourself, find a partner, and let's see if you can find the one in each row that doesn't match. Okay? We're gonna find the one in each row that doesn't match. If you need to use your unit circle, go ahead, but we need to start getting means on that. Because on your quiz, I will not give you a unit circle. I mean, obviously you can make one out of a corner or something on your own, that's fine. But you're gonna have to make it on your own. Okay, so we're working on this paper. When you find the one that doesn't match, on the back side, write down, so it's like if the number that doesn't match, you got a 1 and a 1 and a 0. Okay, the 0 doesn't match. So on the back side, put a 0. Put the answer that doesn't match, the number. Because then we're gonna add them all up and see what we get. Okay? That's how we know if we're right or not. So, let's go. We have 14 minutes. You can get this done. Let's go. When there is a number out in front, like that first one says 2 sine, that means find the sine and then times it by 2.
Yeah, so let's group three. I appreciate that.
So we write the numbers right here.
Yeah. Tangent.
There will not be, the quiz we just took the other day. You had to find the points. That will not be on this quiz. The quiz, a problem like the one we had on our quiz we took the other day.
I'm gonna print also like 30 days on Sunday. Just go on and then just crank it out.
It happens. To have good luck, you gotta have bad luck.
Because this one is just a white.
I didn't write it for you, so I don't. It's negative 4.
This is here.
For this one and canceling out to
We already did this.
I don't think that'd be 1, 2,
5, sine, 2 minus 0.
I did the second row, I don't think I did.
Cosine.
Hey.
No, it's positive left.
I don't know. I don't know how this works. I just cast out.
That'd be in the left.
Sine of 2 cosine of -1.
Pi 2 or negative 3 over
Tangent one's
negative 2 over 2. Yeah. Negative
Oh, those are the
Yeah, you're right. I was thinking over 3, but it's positive root 2 over 2 divided by negative. You got the quadruple. That's what I'm saying. Oh, wait.
I have a 4. The X and the Y are the same, right? So when you put one over the other, you're automatically 1.
Oh, yeah.
Now, if you're going to be positive 1 or negative 1, that might change.
Right.
So it's going to be
0 divided by negative.
So if the one doesn't matter. Okay, yeah.
Six not
Hey, is that like the
Oh, it's literally 3.
Negative root 3 over 2, I think.
That's me with a T, bro.
What's negative?
Or no. Maybe in sine. So it's sine 7 pi over 6. Oh, which would have been 81 negative 1. You're just looking at the wrong order. Yeah. No, because it's sine, so it's the
5 more minutes. Get it done, guys.
That would be 1 half over 2.
Would that just be
Sine of 11 pi over 6, negative 1 half. So the
And so this is like you would
tan of pi.
this is you would bring
Tan of pi. That's 0 over 1. Yeah, 0 over negative 1.
Man, you crazy.
Metal cylinder.
Wait,
cancel out with
The coordinates would be negative 1/2.
Tan pi, it's negative 1 pi 0 is the, yeah, and it's y over x.
Makes me feel comfortable.
0 over negative 1. No, it'd be if the denominator was 0. So, 0.
Really? How did you get that?
Sine 3 pi over 2.
What's sine x over y over y?
There's 6 of them all together. All of it come down to 5 or 6 hundred. So you get everything all the time.
Yeah, be root 3 over 2.
No, that's not what I got.
Wait.
Alex, that means I didn't get it.
What's coordinates? Coordinates. Think, I'm not
Wait,
like,
11?
because I get 1/2.
The y.
Root 3 over 2.
Oh, it said the y. Wait, sine is the y.
Negative root 3 over 2.
I just added.
Wait, do we get? Yeah.
Then cosine of 6. But percentage to x should be negative negative 3 over 2.
Are you guys done?
Root 3 over 2. Yeah.
It'll be negative root 2.
We're not done yet. Oh, it's 1 half. Negative.
What? Okay, so I was saying I was first saying the quarter 1 0, then I was saying the fraction 0 1.
Got 2 more minutes to get them added up, guys. So 2 different people have asked me, can you get no solution? And the answer is yes. If you're doing a tangent problem and you are trying to divide by 0, that is not going to work. Undefined, right?
So is it accepted for the y value, so it'd be negative root 2 over 2.
Winner!
Cosine 3/4, which is on the second quadrant, that's a pi, or that's a negative x.
Look
Pi 1 out of 1.
This is for it, isn't it?
I told you. I know what they're doing. No, I didn't have to zero. Wait, no. Oh, that's true.
Alright guys, I wanna get this checked before we have to leave, so. We have 1 more minute.
It'll be negative 1 over 0.
Yeah. It'd take a long time.
That doesn't.
It's pretty small.
Hello, are you doing great? Yeah, was telling him 1 year old bunch.
Yeah. 7C was undefined, right? I was
This gives me a
Oh,
physical.
wait.
They're both over 0.
Gives you a physical.
Oh, wait.
Funny that
5 or
he's so
2?
happy. Such a job.
Oh, yeah,
It
yeah.
is. I feel like all
It is.
0
It is.
happy guys.
Tangent is y over x. If x is 0, tangent's gonna be undefined.
One more.
Don't think it was X.
7, 5, or 6. What do we have, 2 minutes?
Okay, yeah, we're about, you gotta get the answer. So which is the odd one out for question 1? Well, C is the odd one out, and that's 1. Okay, how about number 2? Which one? A, and that is 0. How about 3? B is odd one out, and it is 1/2. How about 4? B is the odd one out because it is -1, and A and C are both 0. Right? How about 5? C is the odd one out, it's -1/2. 6. A, it's 1. 7. B, 0. And 8, A is -1. So when I added all those up, I got 0. So if you're not getting 0, check your arithmetic or go back and check your answers. Okay? This is, that's
You know what song it is? You know the name of the song?
This
Something else.
cosine by pi over 3 is 1/2.
The days.
The day. My notion. That notion stuck in my head.
This is really
Has a little roll remix. Steve Aoki.
It's been in my head.
so you do.
It's not my party food.
I know, that's why it's been in my head.
All right, have a great weekend. Study. Oh, wait.
Yeah.
If you want an extra practice worksheet, I have.
Oh, yeah. Oh, yeah, that's what we need that.
It's not a good call. You don't love it. You shouldn't. You shouldn't want to.
Enzo, you hitting this up? Enzo, you hitting this up, bro?
It's just a bad idea.
I've only done it one time.
You hitting up the extra review sheet?
You should. Do I get points for it or not?
Nope. Eat it.
I know I do. I'm probably gonna be
I don't even know. Damn near Sunday and Monday.
I can grab it, but I'm not.
I'm figuring, I'm gonna do the whole year Sunday and Monday.
I'm gonna do this Sunday and be like,
No preferential treatment.
that's gonna be. I swear to God, all my life.
Anybody else want an extra practice worksheet?
I got one.
You got one, you got one?
I need it. I appreciate it.
Thank you, Miss Ford.
See ya. He didn't burn a hole in his lanyard.
How do you burn a hole in your leg?
Exactly.
Tell everyone about my secret.
I looked at his lanyard, and right back here, there's like a hole in it, and I said, oh my gosh, it looks like someone burned a hole in your lanyard. He said, I did it. I'm like, dude.
Why would you ever do
Exactly. I have no idea. Do you know Cole?
that? No.
Okay, well, it's not surprising, let's just say that. He's incredibly smart, but he does incredibly silly things sometimes.
You guys ever look early today? No. So I can get a spot in senior lot. It's been like 2 weeks since I've been able to get a spot in senior lot.
Well, maybe if you got here earlier, it wouldn't be a problem.
I know.
You need to do something.
Yeah, I just went back.
I was trying to make it possible for people to like actually walk to their seats.
Yeah.
Oh.
Hello.
Hello, Samuel.
I'm looking forward to class.
Is that your iPad, Oliver? Somebody went into the charger and I said no. Yeah. And somebody removed my
Are you
thing.
sick this morning?
I got something going on, not sure. I feel
Sinus?
fine, but
Well, that's good. Well, maybe,
Oh, I can
might,
hear it.
might hit, hasn't hit yet. Maybe.
You might not for me, I had stuff you know yet.
thank you. Okay. Were we holding hands or something or what?
No, you sat next to me on my.
Oh, I did.
Oh.
I did.
That actually might be it.
Thanks.
I breathed on you. That's messed
Okay.
up.
But no, I don't think I'll
Really?
I was in
You
last
have
class
smile
and me and mom thought
class.
Iggy
This
had
is like
played
a happy
Missouri.
period, okay?
It was Ben Big Bill, Big Bass.
We got two.
Hi.
We got two
What
scatters.
is New
I
Jersey?
just almost called you the wrong name.
What'd you say?
I almost said Will.
It's not your $10 gift,